So how can you be able to have the quadratic equations now given the roots? Now the general form of the quadratic equation, mind you, it is given as given as, in this case it is given as ax squared should be plus bx plus c is equal to c. So this is the general form of the quadratic equation. So in this case we have a being given as the constant and the b constant as well, and also c being given the constant. So c is said to be the y-intercept, so I take note of that. And say we have, let's say, x is equal to 2 and x, let's say, is equal to 5. So now what is actually a quadratic expression in which these roots were based from? It should be a quadratic equation in which these roots were based from. So now you have to understand that having x actually is equal to 2, it is the same as having it as x minus 2 is equal to 0. And having x minus actually is equal to 5, it is the same as x minus x minus 5 is equal to 0. Hence x minus 2 and x minus 5 are the factors of the quadratic equation which have to develop. So in this case it is the same as having x minus 2 and the terms x actually minus 5 is equal to 0. So since both are the factors of the quadratic equation to be actually developed, so now going to expand this, so have it as x squared and minus 5x minus 2x and plus 10, which is equal to 0. So now have it as x squared minus 7x plus 10 is equal to 0. So now this is the quadratic equation corresponding to actually those roots. So take note of that, where you see that this is actually a value of b which is negative 7, and we have the value of c which is given as that of should be positive 10, and always the value of a is given as 1. Whenever we are being given the roots only, always the value of actually a, which is the coefficient of x squared, is given as 1 always. What if we have, let's say, x is equal 1 over 2 and x is equal, let's say, 5 over 2? Let's say that's the case. So what is the quadratic equation corresponding to these roots? So now principle remains the same. We'll have x minus half is equal to 0 and x minus 5 over 2 is equal to 0. So which means x minus half and times x minus 5 over 2 will be equal to 0. So now have it as x squared and minus 5x over 2 and minus x over 2, and there should be that plus a 5 over 4, which is equal to 0. So now these are like terms, so have to add them. Now have it as x squared, now have it as negative, and that should be 6x over 2 and plus 5 over 4. Since the denominator is actually are the same, we just have to add up the powers. Rather, we just have to add up the numerators. So negative 5x, negative x, we'll have it as negative 6x. Otherwise, you should have to express this one as a single fraction, and of which you can have that and as that, so which is equal to 0. And of which you think of saying x squared minus 3x plus 5 should be over 4, which is equal to 0. So that is, so which means we have b being given as negative 3 and c is given as 5 or 4. So that's how we do it. And how about if we have this case, let's say should be, let's say, given as, let's say we have a root 1 given us, let's say, should be root 1 is given us, let's say, should be m, and we have root 2 that is being given us, let's say, m plus 2. So now, what is the quadratic equation corresponding to actually these roots? So let's say we should have to present r1 as well as r2 in terms of x. So have x is equal to m, and another x is equal to m plus 2. So in that case, we'll have x minus m is equal to 0, and x minus, so should be x minus m plus 2 is equal to 0, and of which you have it as x minus m times x minus m, and it should be minus 2 is equal to 0. So that one. Now we'll have to expand here. We'll have x squared, and I'll have it as minus xm, and minus 2x, and minus xm, and plus m squared, and plus 2m, which is equal to 0, and of which you have it as x squared, and that will be given as xm. We'll have it as negative 2xm, so negative 2xm. Now have it as minus 2x, and plus m squared plus 2m, that which is equal to 0. So now have it as x squared minus, that should be minus x, and I'll have it as, should be, we'll have to factor out x here for these two terms. Now I'll have it as negative x, and also should have to factor out a negative as well. So now I'll have it as 2m, and plus 2 should be that, and the whole of this one is the constant, so have it as m squared plus 2m, which is equal to 0. So this is the quadratic equation, and corresponding to the given roots, so which means it is Stromer in form of ax squared, and plus bx, and plus c, where c is the whole of actually those values. So take note of that in case you ask it to. Let's say have x is equal to the square root of 2 over 5, and x is given us, let's say, negative 1 over square root of, let's say, the 2. So what is the quadratic equation corresponding to these roots? So our principle remains the same. We'll have x minus the square root of 2 over 5, and at times have x plus 1 over root 2, which is equal to 0. So in this case, we'll have it as x squared, and plus, so should be plus x over square root of 2, and the minus should be now x square root of 2, now should be this square root of 2x. So now square root of 2x over should be 5, and that will be minus, now we'll have it as, should be a square root of 2 over a 5 a square root of 2, now which is equal to 0. And of course we'll have to express this one as the single fraction, and of which we may think of x squared and plus x, we'll have to factor out x for the two times. So have it as 1 over a square root of 2, the minus the square root of 2 over 5, that is minus root 2 over 5 root 2 is equal to 0. So is it actually, is it so? Now we'll have, that should be this, and that should be that. Of course now this one will have to cancel, I was first surprised there. What is going on? So I have to cancel there. Now I'll have that as now negative 1 over 5. So it should be that. Of course, you have to express this one as the single fraction, but that's how you have to understand that one up to. Now we also have another method in which we can be able to have the quadratic equation given the roots, apart from this one. So you choose which one is best for you, but you should have to get it. Let's say we have x. We have, let's say, x is equal to negative 2 and x is equal to, let's say, negative 3. So in this case, this is regarded as root 1 and this is regarded as root 2. So negative 2 and negative 3. So from the fact that generally whenever we have been given the roots and the quadratic equation we obtain, always the value of a is given as 1. Now what is the value of b? So we should have to go to have the value of b with a formula that says that negative r1 plus r2, and the value of c is given as r1 times r2. So that's the value of c we obtain. In other words, this formula actually it tells us to have a value of b first and the value of c first, and I just have to substitute into the general expression or the general expression for the quadratic equation. So that is, so what is the value of b? Negative, what are the roots we have? Negative 2 and minus 3. That is the given as negative 5, which is given as the positive 5. And on the c we'll have it as r1 times r2, now which will have it as positive 6. Now the quadratic equation has got the general form x squared plus bx plus c. Now we just have to substitute to have x squared, and should be plus 5x, and should be that of plus 6, that which is equal to 0. So that is, and what if you have this case? Let's say we have it as this case. Let's say we have, let's say x should be m is equal to, let's say, negative 4 and m is equal to, let's say, 1. So in this case, this is root 1, negative 4, and this is root 2, that given as 1. In this case, we'll have a is given as 1 always. And what is the formula for b? We'll have root 1 plus root 2, so should be that. And the c is given as root 1 times root 2. I saw that one. So have b being given as negative. What is the root 1? We have it as negative 4. And plus a positive 1, that will be given as, now have it as a positive 3. So have that and as that. And what is the c? We'll have it as negative 4. Then we'll substitute to the general form, where now we'll have it as m squared and plus 3m and minus 4. So that is the actually should be is equal to 0 here. So that is the actual equation corresponding to those roots. And also at your own time, try to have the following. You should have to deduce their actual respective quadratic equations that are given the roots. So we have, let's say, a y is equal to 2 plus, let's say, 2 plus, let's say, pi. Should be this. And we have another y given as half. So try that one out. Let's say if we have x is equal to 2 plus square root of 2 over, let's say, 4, and we have x being given as, let's say, 2. So try to have that one out. Let's say we have, let's say, x is equal to negative half and x is equal to, let's say, 0.5. No, should be that. So what is the quadratic equation corresponding to those roots? And what if we have x is equal to negative, let's say, 1 over 3 and the x is equal, let's say, 3 over 7. So what is the actual quadratic equation that corresponding to those lots? So try to have those problems of at your own time.